Welcome back to the navigation bootcamp. In the previous module, we discussed about map sources of India, which allow you to identify a lot of useful terrain details to plan your route through new unexplored regions of the planet. In this chapter, we're going to talk about global positioning system, which is basically modern day based navigation using GPS, which is ever present now, given the availability of good GPS receivers in most of the mobile phones and GPS watches. With GPS, we will be able to identify our position on the planet uniquely and also cross-reference that same position with any georeferenced map, which we'll be discussing in the next chapter. So let's take a look. What is GPS? GPS is basically nothing but a constellation of around 30 satellites launched in the previous decades by the US Department of Defense. These 30 satellites will basically be transmitting a signal which can be picked up by any military as well as non-military civilian receiver in your mobile phone and running watches to basically identify your exact location on the planet. Positioning is done using triangulation. You need a clear view to the satellites, obviously, so GPS is not going to work indoors under a concrete roof. You need a clear view to 3 satellites to find your exact location identified by a latitude and a longitude. And a 4th satellite is needed if you also want to identify your height or elevation, basically. So how does positioning work on the planet? Let's take a closer look. Let's probably go to Google Earth, where we can show it interactively. GPS has basically divided the planet in 2 different ways. First of all, there are several circles here. The circles can be enabled using the view menu grid. So you can show them by enabling the grid. If you keep the north on top, so we have the circles running from the north to the south pole here. And you can see various circles, 1, 2, 3, 4, etc. So these are basically the longitudes. The 0 longitude corresponds to the prime meridian of Greenwich. Greenwich, basically a town in the UK through which this 0 longitude will run. And as we know, being on a globe, being a sphere, and the circumference of the planet is basically 360 degrees. So if you go around the globe, fully we'll have a total of 360 degrees of longitudes, which will be divided in 180 degrees east, covering Africa, Europe, as well as Asia, and the 180 degrees western longitudes, which are shown here, west 10, 20, 30, 40, 50, which cover obviously the Americas, US, as well as South America. So for example, if we take western longitude of 50 degrees here, then basically it shows this circle from the north to the south pole. And basically any point on the planet here below this circle will be identified by a longitude of 50 degrees west to the left of the prime meridian of Greenwich. So these are the longitudes which basically divide the planet in these type of circles. We also have the other circles which kind of are 90 degrees on top of this. Starting with the equator. Equator basically corresponds to the middle of the planet, you can say, in the middle between the north and the south pole. This is called 0 degrees latitude. Anything on top of this basically will be called 0 all the way to 90 degrees. The North Pole will be called northern latitude. Anything below the equator from 0 again to 90 degrees on the South Pole will be called south latitude. So here we can see 10 degrees south, 20 degrees south, 30 degrees south, 40 degrees, all the way till 90 degrees touching the South Pole. So now basically every place on the planet can be seen as an intersection between a longitude here. Say, for example, this point is identified by the longitude 30 degrees east from the prime meridian. This circle intersecting with the 10 degrees north of the equator, 10 degrees northern latitude. So this point can be identified as 30 degrees east, 10 degrees north. Of course, talking about degrees, degrees are pretty rough numbers. The entire circumference here along the equator corresponds to 360 degrees. And as we remember, all of us from history class, this is around 40,000 kilometers. Converting this in miles, 1 nautical mile, and we talk about nautical, not land miles here, 1 nautical mile corresponds to 1.852 kilometers. So that basically converts these same 360 degrees in 21,598 miles to cover the entire circumference of the planet. So 360 degrees corresponds to this, which basically means 1 degree corresponds to 1/60th of this, means this will be equal to 60 miles, which is again a pretty long distance. So to accurately identify our position, we further divide a degree in 60 minutes. So 1 minute corresponds to 1 mile, which is basically the definition of a nautical mile. It corresponds to 1 minute of longitude, or latitude. Further dividing the mile into 60 seconds brings us to 1 second equal to 31 meters. And then again, if we talk about tenths of seconds, then we come to a precision of 3 meters, which is basically the accuracy of most civilian GPS receivers. Okay, so let's go back now and, for example, zoom in a little to home sweet home, Chennai. If we go to Chennai here, search, and take a look what is the longitude and latitude of Chennai. Chennai obviously is located east of the prime meridian, so we'll have an eastern longitude, and it's north of the equator, so we'll have a northern latitude. So we look at the intersection again of this circle here. This north to south circle corresponds to 80 degrees 15 minutes east. Intersecting with this line, this is the latitude corresponding to 13 degrees and 6 minutes north. So this intersection is uniquely identified by those two numbers. Zooming in a little bit further, let's go to the beach along which I usually run in the evenings, Bessie Beach. And let's just pick up some random point here. I can see the famous memorial here of, okay, not shown now. Let me mark this landmark here on the beach. Voila. So this place is now uniquely identified by 80 degrees, 16 minutes, and 19.49 seconds east of the meridian, prime meridian, and 12 degrees, 59 minutes, 57.75 seconds north of the equator. So voila, there you have it. You mastered now the art of GPS identifying any point in the planet using a latitude and a longitude. Okay, let's take a look further now. So the same with the GPS data formats, right? So as we record a trail using a GPS receiver in a phone or a watch or whatever, or a dedicated, like say, Garmin handheld GPS receiver, what this device will do is it will basically record a sequence of what we call track points, waypoints, track points. So it's basically going to record, say, depending on the seconds, on the settings, say every 5 seconds, it's going to record the exact latitude, longitude of your exact location. It will also record the elevation actually and a timestamp, right? 5 seconds later, as you walk along the trail, it will identify your new position in latitude, longitude, elevation, and timestamp. So that's basically how we uniquely identify any route, any trail, which we have been working with also in the previous chapter. This is the format, XML-based format used by GPX, the standard GPS data format. Also pretty much used frequently as the KML format, stands for Keyhole Markup Language. It's another XML-based format, mostly used by Google Earth, Google Maps. So here again, you'll see a different notation, but the same thing. It's a sequence of latitudes and longitudes and elevations. Okay, so one other interesting thing is if you open let's say the previous module, we downloaded the GPS trail for Sidagat. If you open this one and generate what we call an elevation profile, it's gonna pick out the elevation points from the GPS file, and it's basically against the horizontal distance that you have walked. It's gonna plot the various heights that you covered. So starting at the base at 141 meter, you climbed up slowly initially, and then a little bit more steeply, and then very steeply to the top of Sidergat Fort, 977 meter. Went along the fort for a while, like 1.5 kilometer here, and then again started descending steeply, less steep, a bit steeper, and again gradually into the valley. So this gives you like a kind of a vertical view of the elevations that you have recorded in your GPS file. Okay, time for some hands-on. Let's go to the map now and let's do a couple of practical assignments. Let's first of all start with the Sahyadris. Let's go to Alang Fort. There we go. Basically, I'm here back in my first map, which I created in the first assignment. So you can go to this same map and basically add Alang Fort to your map. Again, any mapping application, any on the mobile, on the desktop, everything will work in latitudes and longitudes. So let's copy this one and let's do a little bit of mathematics here. So Alang Fort, my first point, is located in India. So we talk about northern latitudes and eastern longitudes. So this is now shown in decimal degrees. So if you want to convert this back into the familiar notations of degrees, minutes, and seconds, then we'll have to do a small calculation. So let's open our calculator. Here we go. Voila. So this basically corresponds to 90 degrees. And then what remains is 0.58, sorry, 58317. So if we multiply this by 60, then we get the minutes. So this is 34 minutes. Subtracting the minutes again, what remains is seconds. Multiplying this by 60 gives us 59.4 seconds. 4 is enough, as a tenth of a second corresponds to 3 meter precision, which is pretty much accurate. Same for the longitude. We have 73 degrees east. What remains is 0.66089, which will be minutes. Multiply this by 60 gives us 39 minutes. And then again, minus 39 gives us the remaining in seconds. Multiplied by 60 is 39.2 seconds east. Voila. This is Alang. So if we make a small map, maybe enable the contour map here to see a little bit more. Okay, so now let's take one more point, say Kulang Fort, which is nearby. There we go. Kulang, again, we add it to our map. And again, we get the exact location in latitude north, longitude east. There we go. So north and east. So if we just maybe visualize this a little bit more comprehensively, voila, here we have the map. Let me take a small screenshot of this, put it in a paint application, take whatever I want here. There we go. Paste it. Okay, so basically talking about the longitudes, sorry, here are the latitudes, the horizontal circles we saw in Google Earth. Voila. And here we can also display the vertical circles, which are the longitudes. Voila, there we go. So we had already calculated for Alang as being, this corresponds to the specific latitude. And this one was corresponding to the longitude of Alang. So let's do a similar calculation now for Kulang. There we go. Back to the calculator. There we go. So this corresponds to 90 degrees. Same degrees, because 1 degree corresponds almost to 60 miles, a pretty long distance. Whatever remains here now is 0.59332. Multiply this by 60 will give us the minutes, 35 minutes. And then again, subtracting the minutes, what remains is the second, multiplied by 60 gives us 35.9 seconds. 35.9 seconds north. Similar for the longitude, 73 degrees east. What remains is 0.63853. Multiply this with 60 will give us the minutes, 38 minutes, and then minus 38. Removing the minutes, multiplying by 60 gives us the seconds, 18.7 seconds east. Okay, so let us also add this to our small reference picture here. So we have this latitude corresponds to this exact latitude, and this vertical line corresponds to this specific longitude. Voila. So now on a map, we could start calculating the difference in terms of latitudes and longitudes between both locations. So we could calculate the difference in latitudes between Alang Malang this way, and the difference in longitudes between both forts, measuring the distance between these two vertical lines. So if we do that roughly, what do we see? So let's have the difference now in latitude and longitude to just get a little bit more familiar with this new numbering system. So latitude again, if we subtract both the latitudes, what do we have then? We have 19 minus Coulomb's latitude here. Voila. So we have basically this difference in degrees. So if you multiply this by 60, we get minutes. It's still less than a minute. So again, we multiply by 60 to get seconds. So we have 36.5 seconds difference. 36.5 seconds is the difference in latitude. So let me immediately show it here. This is 35 seconds between the latitudes, latitudinal difference between both forts. And then similar for the longitude, we can just make the difference again, paste minus the longitude of Coulomb is, voila, it's so many degrees, multiplied by 60 gives us minutes, 1.34 minutes. So 1.3416 minutes basically. Minutes, voila. Or if we abbreviate a little, we could say like this, 1.34 minutes. Okay, so what we looking at this distance is basically 1.34 minutes difference between the longitude of Coulomb and the longitude of Alang. So converting this back to what we're familiar with, like meters, say, for example, so then it's pretty simple. 36.5 seconds multiplied by its 31 meter per second gives us 1.1 kilometer roughly, 1,131 meters in latitude difference. So again, we can make a note here. This corresponds to so many meters, so almost 1.1 kilometer difference north to south. And then subtracting the minutes here, 1.34. So 1.34 multiplied, 1 minute is 1,852 meters. Boom, gives us 2,481 meters. So this will be the difference, which we can clearly see the difference between the longitudes is slightly bigger, more than double than the difference between the latitudes. Voila, we can probably save this. This will be a GPS assignment. We'll request you to do a similar, let me save it in JPEG format. It will be easier to manage. We'll give you similar assignments between two other points, same, but this gives you basically a very good understanding how to calculate differences in terms of degrees, minutes, seconds, latitude, longitudes, and then convert it to meters. If you're gonna work with maps, the maps will all be marked with degrees, minutes, and seconds. They will not be really marked in terms of meters. So, okay, let's go a little bit further now. Let's go back to the map session, yeah, at the elevation profile. Yeah, so before the assignment, one other interesting thing is you can just pick up any map here. In this case, we look at one Survey of India map of somewhere in Nagalapuram, South Chennai, where we went for a trek this weekend. So if you look at most of the maps, American Service, Soviet Army, India, Survey of India maps, you will have the latitudes and longitude mentioned on the maps. So in this case, we have a map where the top corner here corresponds to 79 degrees, 45 minutes east, obviously, because we're in Asia, and 13 degrees, 30 minutes north, right? And then if you look at, say, the top right corner here, you come to 80 degrees. So 80 degrees minus 79 degrees, 45 minutes is a difference of 15 minutes across this map. 15 minutes again will be roughly 15 minutes multiplied by 1,852 meters in a minute, which is basically the definition of a nautical mile, will give you 27.7 kilometers. Is basically, I mean, the area covered by this map. Being a square map, similar, the latitudes start from 13 degrees 15 minutes to 13 degrees 30 minutes. So north to south, the height is again 15 minutes, corresponding to the same 27.78 kilometers. So that's basically it. Okay, so for your first assignment, I want you to do a similar exercise as we did with Kulon and Alan. I want you to basically go again to your map and identify the difference between two Himalayan passes. One will be Indrahar Pass. Voila, here we have it. So I'm gonna hide this previous module here. Again, find Indrahar Pass. Voila, there it is. So we mark this pass here, add to the map, ding, ding. Copy the latitude and the longitude, and again we'll have to do a similar calculation. Voila, here we have it. As we can see, it's further up north, so we are now at 32 degrees rather than 19 degrees previously. And another pass being the Gauge Pass. The Gauge Pass, I'm not sure. Yeah, Gauge Pass is also there. Voila, there we go. So again, you take the latitude and longitude of the Gauge Pass, and you again convert for both Indrahar and Gauge to degrees, minutes, and seconds for both the latitude and the longitude. Then you calculate the difference between both the passes, the latitudinal difference, the longitudinal difference, both in minutes, seconds, as well as in meters. And then you create a small image like this, which you then save. You put it in a public Google album. You can actually put it in the same album which you created for the previous assignment. So we had created an album for the previous modules. Voila, Maps of India. In the same album, you can actually add this assignment also. There we go, GPS assignment. You upload it in the public album. So past time you ensured in the options menu that the album was set public. So then you can copy this link and basically go to ultrajourneys.org, fifth module, global positioning module, where you will submit the link to this album along with your email ID for me to review your understanding of latitudes and longitudes. Congratulations, you have covered another important topic in the navigation bootcamp. Get ready for the next module, which will talk about georeferencing of maps, essential again to identify the exact location of the map on the planet Earth and identify the exact latitude and longitude of any point on that map. That's all.